Dear students, through this video program, I am going to discuss with you about Karnaugh Map. It takes the three stages. First stage, what is Karnaugh Map and its structure? Second one is how to place the terms in the Boolean function in the Karnaugh Map. Third one, the simplification part. Introduction. The Karnaugh Map is a usual device for the simplification and minimization of Boolean algebraic expressions. I mentioned earlier. First, let us see the structure. The Karnaugh Map is a rectangular area which is subdivided into 2 power n cells, one of each possible input combination for a Boolean function of n variables. Suppose if you take 2 variables, the possible input combinations are a dash, b dash, a b dash, a dash b, a b. So that you have to give all the possible placement of these 4 expressions in the table, so that I chose the table with the 4 subdivided squares. That is 2 power 2 is 4. And I look at the placement. This table gives the binary representation. Of course, a dash takes the value 0 and a takes the value 1. Therefore, a dash b dash in this place it is 0 0. And for the expression a b dash it is 1 and 0. Likewise the others. And also the third table gives the min-term representation. This is 0, this is 1, this is 2 and 3. So to remember, you can very easily recall this is 0, 1, 2, 3. And in the case of 3 variable, the variables are a, comma, b, comma, c. And these are the possible inputs. And I look at the placement 0, 1, 2, 3, 4, 5, 6, 7. And this is the corresponding binary representation. And this is more important. Exam point of this is more important. And in this K-map, we take 4 variables, namely A, B, C, D, or you can choose x1, x2, x3, x4. And look at the placement of the elements in the Boolean functions. The possible inputs are up to 16, that is 2 power 4. So look at the placement 0, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, like this. The corresponding binary number representation is given. And if you take the first square, that is in the first row and first column, 0, 0, 0, that means a dash, b dash, c dash, d dash. And if you take the last square in the first row, it is 1, 0, 0, 0, that is a, b dash, c dash, c dash. It's very simple. You take the elements in the order a, b, c, d. And whenever you have 0, put a dash. Whenever you have find 1, put the same letter. So likewise, suppose if you want to know the algebraic structure of the Boolean polynomial for this 1, 1, 0, 0, it is simply a, b, c, d, d dash. And this is more important to remember this placement. So once again I repeat, this is number of squares 4, 4. So 4 rows, 4 columns, and the number start with 0 and end with 15. And look at that A. So I put a line here that indicates the third column and the fourth column. The first letter is A itself. But whereas in the first column and the second column, the letter A takes the role A dash. So every square, here it starts with A dash, here also A dash, here also A dash. Like that B placement is the middle, second column, third column. It occupies B itself. And the first column and the last column occupy B dash. Therefore, A and B take the columns, and the remaining two variables C and D takes row wise. First let us C. The third row and the fourth row occupy C itself, and the first row and the second row takes C dash, and the last variable D take the middle like B, and the first row and the last row occupies the complement, that is D dash. Therefore, if you take that file, if this take this file, and here the A is the complement, therefore here A dash, and B is here, therefore A dash B, C dash and D. So this is A dash, B, C dash and D. So likewise you can represent all the algebraic expression for these binary numbers. And how to represent a Boolean function in a K-map? Suppose these are the three terms in the given Boolean function. This is nothing but 3, 4, 5, that is 0, 0, 1, 1, that is 3. 0, 1, 0, 0, that is 4. 0, 1, 1, that is 7. Therefore, for this table, we need to place 3, 4, 7. So, in that for the further calculation, we need some identification. Therefore, I am put a 1 in green color. 1, 1, 1. And this is the minimum algorithm for Boolean polynomials. And these are some steps I will explain by taking the following examples. Minimize the Boolean function using K-map, and this is the given function. And the corresponding min-term representation is this one. This is 3, 4. This is nothing but this 0, 0, 1, 1. So whenever you have dash, put 0. Whenever you have no dash, put 1. So this is 0, 1, 0, 0. 0, 1, 0, 0 is 4. Like that. And you can simply, as earlier I indicate, put 4, 3, 4, 3, 4, 5, 7. This is 5, 7, 9, 9 here, 13, 14, 15, 13, 14, 15. So this is a way to represent the given Boolean function in the Boolean